Welcome friends. So, in our previous session we discussed that how predictive analytics is helping us in solving the situations where we have more complexity in our data. We introduced two cases, one where we have a trend and one where we have trend and seasonal factors also in our historic data. Now, in that case, how are we going to solve our situations, that are we going to discuss in this particular class. Here, if you see, we are going to discuss primarily the case of trend and seasonal variations. We discussed in our previous session that you know these types of models under the name of winter model, where we have both trend and seasonal components. Now, when we have trend and seasonal components in our data, like for your refreshment, I am saying that this type of models are possible when you have both trend and seasonality in your data. Now, in this particular case, if you have trend and seasonality, our answer will come with this equation. The systematic component of demand, which is going to be our forecast, will come with level plus trend into seasonal factor, and seasonal factor which I am assuming in this equation is a multiplicative factor. So, I will calculate for my next forecast FT1, I will calculate the current levels trend LT plus TT and I will multiply it, please remember, with the seasonal factor of the respective time for which I want to get the forecast, that is T1. Please remember this very important thing. And if I want to calculate the forecast for n period, it will be possible to do. If I do not have that much of data, I can do with the help of this current data, where this is LT plus NT into I Tn. This is the big mistake many of us do when we are using the winter model for our forecasting purpose, that you have to use the most commonly what we do. Let me tell you what majority of us do, that is LT plus TT multiplied by IT. This is what most of us will do. You are using current trend, current base and current seasonal index. That is what you are going to do most of the time, but this is wrong. This is correct. So, please see that you should use the appropriate seasonal factor, use of appropriate seasonal factor is required in the winters model, or in this case of where seasonality is also present in your demand data. Now, how are we going to do this? This is how you have the detailed mentioned here, that it is FT1, that is the forecast for the next period I am going to calculate, LT plus TT multiplied by ST plus 1. This you please remember what I was just explaining. And if I want to forecast for L period ahead, LT plus LTT, this is T plus L. This is again a mistake even by me only. This will be LT plus L, that I have to calculate, I have to use the seasonal index of L period ahead. Now, going with this, I have to update regularly my base, my trend and my seasonal factors. And for calculating those things, I am using 3 smoothing constants alpha, beta, gamma. First, I will calculate the initial values of base, initial value of trend and the seasonal factors S1 to SP if there are n number of different types of seasonal factors, because your data may have seasonality at a particular interval, most likely monthly seasonal, in some cases half yearly, in some cases quarterly. So, depending upon how many seasons are there, how many periods are there in a particular cycle, based on that the seasonality will be calculated. Now, first, and I hope you will remember my equation that for calculation of ST, TT or LT, alpha A plus 1 minus alpha B, this equation is the most generic equation. So, you have to replace alpha and A and B as the case may be, whether you are calculating the seasonal index, you are calculating the trend or you are calculating the level values, accordingly your A, B and alpha will change. For example, if I am calculating level value, it is alpha dt plus 1 minus alpha st minus 1, LT minus 1. If you remember the original equation when we were talking of simple exponential smoothing method, your LT1 was alpha dt plus 1 minus alpha LT. Now, if this was A here, this was B here. In the current circumstances, this will be alpha dt plus 1 st plus 1. dt plus 1 upon st plus 1 is basically deseasonalized demand. This is the deseasonalized demand of the current period, and this is LT plus TT, which is B here. Similarly, when I am calculating the updated trend, it is TT plus 1 LT plus 1 minus LT, that is the current trend minus the existing trend. And then here you see this T plus P plus 1. Using my current data, let us say if I have monthly data and I am currently in the June. So, if I want to calculate LT plus 1, let us say it is L June, TT plus 1 it is June, and ST plus 1, ST plus P plus 1 is S June 2025. All these are June 2024, this is also June 2024, but this P means number of periods. So, in fact, in my current calculation, this ST plus P plus 1 has no use. In the current calculation, this ST plus P plus 1 will have no use. This ST plus P plus 1 will be used when I will move to year 2025, when I will be requiring this value when I am in the month of June 2025. At that time, when I will be looking for forecast for July 2025, when I am in the month of May 2025 and I want to forecast for June 2025, this updated seasonal index will be used at that time. So, we are doing these calculations for a future period, not for immediate period. So, L and T will be calculated like this, and third, the updation in my seasonal index will be done with the help of gamma A plus B, and this is the seasonal index d t plus 1 upon base value plus the existing seasonal factor. Now, all these three alpha, beta, gamma between 0 to 1, and as we have continuously saying, popular values of these coefficients are between 0.05 to 0.30. These are the popular values of alpha, beta, gamma, and we use a lot of forecasting error measures for deciding what are the correct values of alpha, beta, gamma. Now, this was the data we were discussing in our previous session also, and with the help of this data, you see here our seasonality is coming in the quarter. So, you have 4 periods in a year, and then again the data is going to be revised. So, year 1 is having data of only 3 quarters, first quarter data is missing here. For year 2, we have data of all the 4 quarters, and for year 3 also we have data of all the 4 quarters, and for year 4 we have data of first quarter. So, in fact, you can easily understand our forecast requirement is for year 4 quarter 2. Now, before I go to the next slide, I will like to ask you what, and I request all of you that before I write, you should also try that what should be the equation for getting the forecast for year 4 quarter 2. Year 4 quarter 2 equation will be, you have to calculate the L for year 4 quarter 1 plus trend for year 4 quarter 1, which will be multiplied by seasonal factor for year 4 quarter 2. This is the forecast for year 4 quarter 2. So, my duty is now to calculate all these 3 terms, level, trend and seasonal factor for year 4 quarter 1, year 4 quarter 1 and year 4 quarter 2 respectively. And to start this process, let us first understand how we are going to do this. So, initially we are going to have these initial estimations of S1, S2, S3, S4. Now, how these S1, S2, S3, S4 estimations are coming? For that purpose, you can take the average of all the demand and you need to divide the demand of a particular period by the average demand, and that will give you the S1, S2, S3, S4. Sorry, we have only 3 quarters data given here. So, you have S1, S2, S3, and then you may use these S1, S2, S3 for continuously updating your data to the use of this particular equation of updating the seasonal factor. And with this, now to show you that how these calculations are going in a flow, we will like to show you a example in the Excel format, so that you can easily understand that how these calculations can flow in a automated manner. So, now we will go to the Excel sheet and where we will see that how all these data are flowing in a systematic manner. So, let me stop this and go to the Excel sheet. So, here if we see the data which is available to us, it is a slightly longish data, so that we can understand the calculations in a better way. We have given you the data of 5 years, and every year is divided into 4 quarters, 1, 2, 3, 4, like that. Here I am requesting you initially to focus only on first 3 columns C, D, E, where we have quarterly data available to you. Now, using this quarterly data, we are first required to calculate the seasonal index. Now, how we have calculated the seasonal index? For that, given you the calculation of seasonal index. Now, for quarter 1, quarter 2, quarter 3, quarter 4, the data which is given to us 2250, 3514, 4120. If I use the data of quarter 1, and these. So, the average demand of these quarters are given to us is taken here, that is the average of, if you see in the formula bar, is the average of E7, E11, E15, E19 and E23, what I have encircled just now, and that average is coming 4205, 4205. And similarly, we have done the calculations for average demand for quarter 2, quarter 3 and quarter 4, you can see in this particular column where average demand is there. Now, after getting this average demand, in fact, please do not see this column. Let us come back to the column number F, where we have the demand of a particular period divided by the average demand for that period. So, like you see 2250 divided by 4205. If you see the formula which we have inserted in column F for cell number F7, so that is directly we have transported the value from column T here. So, if you see the value in the T7 0.83, if you see this 0.83, this is S7, that is this value, divided by S7 to S10. So, S7 to S10, that is these average of these 4, and the value which we are having in this 4205, that is like this. If I explain this to you, it is 4205 divided by average of 4205 to 9542. So, same way we have done for all the other calculations, 2945 divided by the same denominator, 3517 divided by the same denominator, and 9542 divided by the same denominator. So, you can see that because of the seasonal impact, demand of the quarter 4 is increasing almost double to the average demand of all the quarters, but quarter 1, 2, 3 the demand is relatively low, it goes very low in quarter 2 and it jumps significantly in quarter 4. So, these are the initial seasonal index, these are the initial seasonal index which we have put here. Now, our focus is required in this part. Here our seasonal index which we have directly taken from column T, 0.83, 0.58, 0.70 and 1.89 or 90, for that purpose rounding off has been done. Now, initial levels and initial trend are given to us. Let me go to cell number M6. If I go to M6, this is C56 and C56 is coming with the help of my regression calculations. So, let me tell you that to get the initial values, initial L naught and T naught that we already discussed in our previous session can be used, that whatever data you have, if you put that into a regression equation. So, this intercept on the y axis is L naught and the slope of this line is our T naught. So, we have used the data of if I go to upside. So, the initial data of my demand and period, if I use this historic data, so this gives me the scope of creating a deseasonalized demand, because when I am talking of 2250, 1737, 2412 etc., there is a seasonal component of 0.83, 0.58, 0.70, 1.89. So, with this seasonal component, this regression equation is not possible or will not be a good idea. So, what I need to do? I need to deseasonalize my given demand, and for that purpose, if I go to column I, here what we are doing, that we are dividing the demand, whatever is the current demand, with the seasonal factor corresponding to that particular period. For example, this calculation 2703 is coming by 2250 divided by 0.83, because 0.83 is the corresponding seasonal factor. The next is coming 2980, which is 1730 divided by 0.58, and so on. We are going for developing my deseasonalized initial demands, and then using this deseasonalized demand with periods, if I go to regression equation, I get the coefficients of my regression equation, where the y intercept is coming 2644. So, that is my L naught, and the T naught, that is the slope of this line, that is the trend, that is 229. So, we got these values of L naught, T naught to start our process, and that is what we have written here directly as our label and trend. So, this becomes L naught, T naught, and our initial seasonal factors are also given to us. Now, what we are going to do, our forecast therefore in this column, you may remember that it will be L plus T multiplied by seasonal factor of the corresponding period. So, in fact, this 2391, I request all of you to please calculate on your own. This 2391 will come, if I calculate the F1, this is L naught plus T naught into seasonal factor 1. That is the calculation for getting 2391. And similarly, as I go ahead, you see that when I am calculating 1772, I am using the 2822 as my base, 219 as my trend, and the initial seasonal factor which is already available with me 0.58. And now, when I was here at the first factor 0.83, so I will update this 0.83 also, and that updated value of 0.83, incidentally it is 0.83 only, but this updated value is coming here, this 0.58's updated value is coming here. Since the gamma is 0.1, so the impact is not so high, 0.70 becomes 0.71 and 1.90 becomes 1.87. So, the initial seasonal factor for quarter 4 was 1.90 and after year 5 the seasonal factor for quarter 4 has become 1.85. So, in this way there is some changes happening in the seasonal factor, which is going to be more. If I can show you that if I change the value of gamma from 0.1 to let us say 0.20 just to demonstrate, and then you see that the values of our seasonal factor, which was initially 0.83 in the quarter in the year 5 quarter 1, this has become 0.87, some visible change you can see that from 0.83 to 0.87. So, the gamma is not so dynamic, beta or you can say trend is slightly more dynamic and level is even more dynamic. And generally you will say, though it is not a rule, generally you will see that in alpha, beta, gamma, alpha is generally more, beta is less than alpha and gamma is further less than the beta. So, here with this kind of static development, you can very easily increase your model, and then you see that some more interesting things in this table, because you can see now various things in a glance. Now, when we are doing this using the Winters method, our forecasting errors are coming for each period as 6.29 to maybe it is going up to 44% in some period, which is relatively very high forecasting errors. And then after all these calculation, you can calculate your MAPE, mean absolute percentage error, which has become very popular in the field of analytics these days. It is coming close to around 11.81%. It is around 11.81%. If I see some other methods also, if I can see the column G and H in this table, where we say naive, that naive means I am not doing anything, whatever was the demand of the previous period, I am considering the same demand for my next period. I do not consider any kind of seasonality, I do not consider any kind of trend, I have no idea of predictive analytics. For me, the predictive analytics is that whatever is the current demand, the same demand will be in the next period. If there is a change, whatever change will happen in the next period, that will be the demand for the further next period. And on the basis of that, you see that our forecasting errors are so high for every period, because this data is not suitable for this kind of methodology. However, this naive method can also work. You can say that it is a kind of a very simplification, highest degree of simplification of our moving average method, where we are taking moving average of just one period. You can say that this naive method is taking the moving average of single period. On the other hand, you have the regression method or Winters method, which are more or less equally powerful. In the regression equation, we are developing y equals to a plus b x, where x is the period and y is the forecast. So, as period is changing, we are having a new forecast. But in this case also I see that whenever there is a seasonal factor, the forecasting error will be very high, like in 4th, then in the 8th period, in the 12th period, you see very high forecasting errors are also happening. The overall mean absolute percentage error is more than 10%. Then you have this Winters method, which we discussed in detail in this class. Here also the forecasting errors are more or less comparable to the regression method. In this class, we discussed the method of 3 constants using multiplicative trends. I request you that please try the same data with the additive trend. Think of additive trend, and when you think of additive trend, the equation for determining the forecast will also change. And I also request that in this particular case, we are doing the calculation with particular set of alpha, beta, gamma values, where we are taking alpha 0.3, beta 0.2 and gamma 0.2. I request all of you to play with the values of alpha, beta, gamma and see if your alpha, beta, gammas are changing, how our forecasting errors and MAPE also changing. We have inbuilt the formula of MAPE also in this table. If I can go to the MAPE, that is Q28, you can see the formula there. So, this is average of Q7 to Q26. So, that is we have calculated the mean absolute percentage error for every column, every values in the column Q, and the average of all these error values, that is giving us our mean absolute percentage error. So, that is how the predictive analytics can be used for improving our estimations for future, and these forecasting models are going to be the base inputs for various other decision making like inventory management, like material planning, like facility planning, etc., which are another important decision areas in our operation management discussions. With this, we come to end of this particular session. Thank you very much.